You guys had a chance to check those? I know there's going to be some you have questions on. So what would you like to see? Page.
1.
Number 1. I'm on the right page, right? You have 8, 0, 3, negative 2, and then the ratio of 1 to 4?
Yeah.
Awesome. Did you graph this one page, or did you do it without graphing?
Yeah.
Say it again.
Yeah, I got it.
Graphed it. Perfect. All right, so we've got. Oh, I bet I know what happened here. We have A, which is at 8, 0. We have B, which is at 1, 2, 3, negative 2. And here's segment BA. And page if the ratio is 1 to 4, we're thinking of what portion of the way from A to B? 1/5. 1/5. Now here's the key. From A to B. Now why is that important? Well, if you found the horizontal change here, you're going from B to A. Okay? We have to go from A to B. And maybe you did that. I don't know. So what is the horizontal change if we go from A towards B? Well, it's left. If I went from an x value of 8 to 3, it's left 5. Do you agree with that? And if I go from A's y value down to B's y value, didn't I drop? I went from a height of 0 down to a height of negative 2. Bless you. I dropped 2. Okay. And so we're going to take 1/5 of that change. So 1/5 of negative 5. What is 1/5 of negative 5? You agree it's negative 1?
Negative 1.
Good. So negative 1 horizontally from A to B. Now let's do the vertical change. 1/5 of negative 2, which is negative 2/5. And you could write negative 2/5. You could also write it as a decimal as negative 0.4. From A to B. Okay, so we put our pencil day. And we're at an x value of 8. If we move negative 1 horizontally, we're now going to be at an x value of 7. And again, this is our last step. This is finding that point that's 1/5 of the way. So it's going to have an x value of 7. And the point is called P. X value of 7. And it tells us to go down 2/5. Well, from 0 down 2/5. Well, if we were started at a height of 0 and we go down 2/5, the y value is negative 2/5 or negative 0.4. If we started at 1 and went down 2/5, we'd have to do 1 minus 2/5. If we started at a height of 10, went down 2/5, we'd have to do 10 minus 2/5. But since it was 0, 0 minus 2/5. And again, if you wanted to label it like they did, I put horizontal, they put run. I put vertical, they put rise. Either way is fine. So then you plot the point, and you got that point. And does it look like 1/5 of the way from A towards B? Yeah, looks pretty good. That was a little tricky because of the direction. Going left to right, you saw B first, then A. Make sense now? Other homework questions? Good, Emma?
I have a question on the first part of 21. Because it says like a +2, or it says -2, but I got a +2. After I set it equal to y.
So you're saying, help me out, Emma, +2
At the top.
at the top?
Yeah, the first part. There, yeah.
You're saying right here they got -2 and you got +2? Okay. I would agree with you. They should not have gotten -2. They should have gotten +2. Because when you subtract 5x, you get 2y equals -5x plus 4 divided by 2. -5 halves x, and then 4/2 is +2. They messed up. Now, is that going to affect? Did they use that wrong answer? No, they used it. They corrected it down here, didn't they? So their mistake was just up here. They corrected it when they went to solve the system. So were you okay from there on out?
Yeah,
that was just, they made a mistake up there. Thanks for bringing that up. Let's change it. Any other questions you'd like to see worked out or ask about? Are you sure? You guys are good? Maybe I underestimated you, Alana. 19, sure. Ah, come on. Alana, did you graph this one or try to do it without graphing?
I tried graphing it, and then I just didn't get through it all the way.
Okay. All right. I'm a visual person. I like to see what's going on here. So I would plot the point -1, 1, 2, 3, 4, 5, 6, 7. I'd put A, -1, 7. And I graph the line y equals 3x. Y equals 3x has a y-intercept of 0. And so 0, 0 is its y-intercept. And it goes up 1, 2, 3, and right 1. Bless you. So there's y equals 3x. Find the distance from point A to the given line. So Alana, can you agree that the distance is going to be about the length of that segment? And again, I'm just eyeballing it, but it's about the length of that segment, correct? So again, the process is step 1, write the equation of the perpendicular line. This whole line, find out where they cross to get the point, and then find the length of that segment. All right, well, the perpendicular line to y equals 3x, ... We need the slope of the perpendicular line. Well, what's the slope of this line that I just graphed in blue? The slope is 3/1. So this slope is 3 over 1. We don't want that slope. We want the opposite reciprocal slope. Opposite reciprocal is going to be negative 1/3. Everybody agree? So we're finding the perpendicular line. We need the slope, the opposite reciprocal, negative 1/3. Awesome. Now we want the point. The point it has to go through negative 1/7. So you need to know the equation y equals mx plus b. Y equals mx plus b. The only thing you need to write the equation in slope-intercept form, y equals mx plus b, is the slope and the y-intercept. Good news, we have one of them. We have y equals negative 1/3 x. But this point, negative 1/7, do you agree? Negative 1/7 is not the y-intercept, right? Not the y-intercept. But we can plug negative 1/7 into x and y to find the y-intercept, and then we'll be able to write the line. So 7, so this work right now is to find the y-intercept. 7 equals negative 1/3 times x, which is negative 1, plus b. Negative 1/3 times negative 1 is positive 1/3 plus b. We'll subtract 1/3. And Alana, did you go to decimals here? Or did you write it as a fraction? Or did you get stuck at that point?
I just wrote it as, I don't think I did it right. No.
Here's my caution at this point. If you do 7 minus 1/3, here's 7 minus 1/3. It's 6 2/3, right? 6 2/3. If you write 6.3 repeating and you round it and you say, okay, to 6.33, any calculation after that is going to have to be rounded, which it might be. We'll see if it's going to cause us issues. I'm going to write it both ways. 6.3 repeating, or, nope, sorry. I said that wrong. 7 minus 1/3 is 6 2/3. 6.6 repeating. 6.6 repeating, or 6 2/3. 7, take away a third is 6 2/3, or 6.6 repeating. All right? That's our y-intercept. Where does that go? Well, we bring this equation that was almost done down here. Anyone? What's the equation of the green line? Who can raise your hand and tell me? What does that mean? What does it represent? The green line is... Jackson. This green line. It's not just the slope. What is it? On this picture, the green line is going to be the...
Oh, the distance?
Not yet. What if I graph this line? Let's go ahead and graph this line. This line has a y-intercept of 6 2/3. Okay, 6 2/3. 1, 2, 3, 4, 5, 6 2/3. Ooh, that was pretty good. And it has a slope of... negative 1/3. Down 1. Right 1, 2, 3. Which? Ish. That is the line. Now mine's off a little bit, but that's the line. That's the perpendicular. So the answer to my question earlier, what does that green line represent? It's the perpendicular line that goes through this blue line and also goes through the point negative 1/7. Do you agree? But we don't need to graph the whole line. All we care about is the length of a part of it. Just part of it. Okay? So how do we find out where it crosses the blue line? Well, set them equal. Find out where they equal. So we have the blue line the blue line in our picture is y equals 3x. And this work is to find out where they intersect. The green line was y equals -1/3 x plus 6 2/3. I think substitution is easier here. Elimination, well, I don't know. How many of you guys did elimination? What happens if you subtract the equations? You're going to get rid of y. Do you agree? But then you're going to have 3x minus a -1/3 x, which is fine. And then you're going to have 0 minus 6 2/3. If you set them equal, the y equals 3x, y equals -1/3 x plus 6 2/3, you'd plug this in for y and you'd solve it for x. Okay? So raise a hand. Show of hands. How many of you did substitution? How many of you did elimination? So we'll do substitution. All right, so I'm going to plug in -1/3 x plus 6 2/3 equal to, so I plug this in for y, since it equals y, equals 3x. I'll add 1/3 x to both sides. And are you guys comfortable typing these in your calculator? You might not have needed it for this one. How many times does 3 1/3 go into 6 2/3?
1.
How many times does 3 go into 6? How many times does 1/3 go into 2/3? So do you agree 3 1/3 is going to go into 6 2/3 twice? So x equals 2. What does x equals 2 mean? It's part of the answer so far. It's part of our process. What does it mean? It's the x value where the two lines intersect. We need the y value. I could plug it into either one of these. I'd rather plug it into the top one, wouldn't you? What's 3 times 2? So y equals 6 when x is 2. Y equals 6. And a lot of this goes back to, I'm glad you graphed this one. I think it helps us to visualize, does that point reasonable? 2, 1, 2, 3, 4, 5, 6. Yes, that is reasonable. 2, 6 seems reasonable for where they cross. So now my last step, I don't care about this green line anymore. I'm only using part of it. I'm going from -1/7 to 2, 6, using the distance formula. Distance. Let's do 2 minus -1. Come on, board, you can do it. Plus 6 minus 7. Come on. 2 minus a -1 is 3. When you square it, you get 9. 6 minus 7 is -1, but when you square it, you get +1. I get the square root of 10. Be careful. Some of you on the last quiz, when you did the distance formula, you did the square root of 9 and the square root of 1, and you added them together. That's not the correct order of operations. Leave them. Simplify the inside first, then square root. All right? Square root of 10. I don't get any pairs. That's the simplest radical form would be radical 10. And if we write it as a decimal, it's like 3 point what? Radical 10 is just above radical 9, which is 3. 3.16. So that's how you do that one. It's a lot of work. Okay, I'm not going to try to mess around and say, nobody should miss this problem. It's so easy. Just suck it up and do it. Like, no, it's a hard problem. These are hard problems. But you have all the tools you need. Do you agree? Do you agree? Can you at least admit this? There's nothing new in that problem. Can you write the equation of a line? Yeah. Can you write the equation of a perpendicular line? Yeah. Can you find out where two lines cross? Yeah. Can you find the distance between 2 points? Yeah. But I get it gets complicated when you throw everything together in one problem. There's a lot of places that errors can happen. Okay? So what I need from you guys is to try those and try to get better at them and ask questions, because you're not going to know where you're falling apart until you tried enough of them. All right? So highly recommend it. If you missed one of the homework problems, go back and try it again. Okay? Go back and try it again. I have some new problems for you guys to try tonight. There's some on the review. Are there any other homework questions that you're stuck on? Okay. I would like for you to pull out the 3-1 through 3-4 quizzes. That's going to be part of our review, is to make sure you guys are okay with what you missed on there. We got a new 9 weeks. I'd love for this test to go really well for everyone. It's the first summative grade of the new 9 weeks. Any questions on 1A through D? I think you guys did pretty well in there. If you missed it, you probably figured out what you did wrong. Questions on A through D? 2, you guys did really well. If you missed something, you just kind of wrote the wrong name there. Some of you put corresponding instead of consecutive interior. Some of you forgot the word interior. You have to put interior. They're called consecutive interior. Kelly?
What day did we get these tests back?
It was last week Sunday. I can look to see if maybe you were absent a day. Maybe when I passed them
I
back.
was absent Thursday.
I think I might have passed them back that day. I'll get you in just a second. These two, because the lines are parallel, well, if the lines are parallel, find the measure of those angles. So you don't set those equal. Those are same side interior or consecutive interior. And if the lines are going to be parallel, they should add up to equal 180. You got x equals 10, plug it in, 126. You guys did pretty well on that one as well. To the back. To make them parallel, those two alternate interior angles need to be congruent. X equals 20. You guys did really well on that. All right, now here, number 5, a lot of you kind of, I don't know if you just kind of stopped or what happened, but you didn't fully consider the picture. Do AC and DF have to be parallel? Okay. Well, I gave you this angle is 143. Here is a huge flaw in reasoning that you need to be careful of. Tell me what's wrong with this statement. If this angle is 143 degrees, then this angle is 143 degrees because of corresponding angles. What's the flaw in that statement? Christian?
You're trying to say that they are parallel, so you can't say that they're corresponding.
Perfect. Are they called corresponding still? Yeah. But are corresponding angles congruent? We don't know, because we don't know if the lines are parallel. Here's what I can say. If this angle is 37 degrees, this angle is 143 degrees because they are a linear pair and are supplementary. Is that accurate? Is that accurate? Yes. Linear pair, always supplementary. Always add up to 180. Oh, look. Oh, look. Now these two angles are congruent, not because they're corresponding, but because of, oh, look, I did some math, and a linear pair add up to 180. Oh, look, they're congruent. If they're congruent, then those angles are, well, the corresponding angles were congruent. The lines must be parallel. And you needed to be careful. If some of you said the lines are parallel by the converse of corresponding angles, perfect. Perfect. If you said corresponding angles are congruent, so therefore the lines are parallel, false. That's opposite reasoning of what we're after on that one. Okay. Next one, you guys did pretty well on. Something to be careful of that I did see. Some of you said 3 and 5. I gave you 3 and 5 are supplementary. Some of you put linear pair theorem. What's wrong with linear pair theorem there? 3 and 5, are they adjacent? So they can't be a linear pair. All right. So they're not supplementary by the linear pair theorem. 3 and 5 are supplementary because we were told the lines were parallel and they're consecutive interior angles. So then the definition of supplementary angles is the measure is at 180. 1's congruent to 3 by vertical angles. 1 equals 3, definition of congruent angles. And we converted into the equals world in this one because in step 6, we needed to add up, we needed to substitute. Well, here's a 5, here's a 5, here's a 180, here's a 180. Nothing's been substituted yet. But 1 replaces 3 because up above, we said that they were congruent and their measures were equal. Substitution. And now, oh, look. 1 and 5 add up to 180. That means they are supplementary. That's the definition of supplementary angles. Question on that. All right, next. I'll tell you what, overall, I was pretty impressed. You guys did pretty well in the proofs, okay, as a class. All right, here's the tricky one. This really tested your understanding of, okay, the lines are parallel. I can use those theorems. Or, oh, I'm trying to prove these are parallel. I need to find a pair of blank that are congruent or a pair of consecutive interior that are supplementary. So they told you A is parallel to B. So watching up here, A is parallel to B. Can I say 1's congruent to 2? Yes. Those are corresponding angles. They are congruent because they're formed by parallel lines. Agreed? Those pair are congruent. I could say 1's congruent to 2, corresponding. All eyes up here. Can I say 2's congruent to 3 because of alternate exterior? No, why not, Caden?
Because we don't know C and D are parallel.
And that's the tricky part of this proof. There's one pair of parallel lines, I can use the theorems. There's another pair, I don't know if they're parallel. I'm proving they're parallel. So I need to get there another way. Well, I was given 1's congruent to 3. I just said 1's congruent to 2 corresponding. And something I want to, encourage you guys to go to the next level with proofs is some of you converted to equals in this proof. We didn't have to. I didn't count off if you did. But do you agree if 1's congruent to 3 and 1's congruent to 2, then I can use the transitive property. I don't need to say measures are equal. I can just say transitive property. 2's congruent to 3. Oh, look. A pair of alternate exterior angles are congruent. Not because of alternate exterior angles theorem, because of the transitive property. Oh, look, they're congruent. Then the lines forming them must be parallel. That's the converse of alternate exterior angles. Okay? If you put regular alternate exterior angles, you're missing the point on that one. I don't want you to get confused by that. Next one. R is parallel to S, given. All right, and 1's congruent to 2, given. 3's congruent to 2, corresponding. Why? Because the lines are parallel. If 1's congruent to 2 and 2's congruent to 3, then 1's congruent to 3. And you couldn't say because they're a linear pair. We didn't know that they're a congruent pair of angles yet. You had to use the transitive property to say 1's congruent to 3. Oh, look. There is a linear pair of congruent angles. Then the line must be perpendicular. Remember that one? The linear pair perpendicular theorem? Okay, the linear pair perpendicular theorem. That was and some of you wrote it out in words that matched it. If you wrote out in words one of the other theorems that was in that section, that wouldn't get full points because that wasn't the one that was being used. All right. This one, the hypothesis is that you have a pair of congruent angles that are a linear pair. The conclusion is that the lines are perpendicular. And the last one, just the distance formula. You guys did really well. 4.47 is what most of you had, or 2 radical 5. Any questions for me on that quiz? If there's one that maybe you weren't comfortable asking in front of the class, I'd be happy to answer it for you. All right. Here's what I'll say. That going over the homework took most of class. So the original agenda on the website, just to make sure we're on the same page here. The original agenda, I posted last night's homework answers. I posted the paper that you have in front of you for the test review. And then I put more review problems for homework. All right. I'm going to make that the book problems optional practice. I'm going to say your homework is to finish the chapter 3 test review handout. So the paper you have in front of you is the chapter 3 test review handout. Optional extra practice are the page below. Does this make sense? Is it clear to everyone? I don't want you going home and spending 5 hours doing all this if you are 100% confident what you're doing. That being said, if you are completely confused and stressing out and panicking and feel like you just need extra practice, it's there. Feel free. What's required for tomorrow, though, is to finish the test review. Make sense? All right, how can I help you guys? What can I do to answer questions or help you? We still have some time. Did we answer your questions? Did you feel like you're on the right track? If not, call me over now, please. I'll help you out.